So let's call this curve sketching part 2. So what do we got? H of x is, what is it? X minus the ln of x squared. So we start with the minus sign. As the squared gets lost. I think that can also be written as ln squared x, like we write sine squared x, right? But to make sure that we understand that ln squared x is the ln of x quantities, all squared, we've written it this way in this case. Okay, so A, domain. What's the domain? There's a hint. Bigger than 0. And yet still smaller than a breadbox. So from 0 to infinity, right? Because you cannot do the ln of 0, right? So we go from 0 up. B, what's B? The intercepts. So, so x can't be 0, so there will be no y-intercept, right? And if y is 0, then that means that, okay, so y equals 0 leads to x minus the ln of x squared is equal to 0. Which means that x is equal to the ln of x squared, which means that, so how do we unsquare that? Square root. Okay, now when we do that, it's not just square root, right? What is it? Yeah, well, it's plus or minus the root of x. So it means we have to solve two things then, right? We have to solve the root of x is equal to ln x. Okay. And what did they give? There was some useful information. So the useful information was the root of x equals ln x has no solution. Okay? So that was given, right? No solution. That was given in the useful information, okay? And the negative root of x is equal to ln x is true when x is about 0.49. All right, so now we've used the useful information. And we've done the intercepts. Symmetry, not really worried about it, right? Because there is nothing to the left of the y-axis, so there can't be even symmetry, and there can't be odd symmetry. Symmetric. None. Asymptotes. So, any vertical asymptotes? Yeah, think about ln x. X equals 0, right? So think about the domain. We know that x can't be 0. Now, we only need to approach from above, right? Because it's not defined at 0 or below. So we are just looking at, so vertical asymptote. Limit as x approaches 0 from above of, what was the equation? X minus ln squared x. Or sorry, ln of x squared. And what's that going to be equal to? Yeah. Why?
Because ln of a really small number is a really big negative number.
So this doesn't do anything except lend itself to then we're subtracting a really big, oh, for a different reason than you thought. Okay, so the ln of x is a really big negative number, right, as we approach 0, but then it's being squared, so now it's positive, but then it's being subtracted from a really small number to begin with, so now it's negative again, right? Okay, so it's all right. Nobody knows that you got it right because it was a little faulty reasoning, but hey, nobody asked for an explanation. Well, I did, and then nobody said explain that. Okay, so we got a vertical asymptote. So you could do a preliminary sketch, right? I don't think we really need to bother too much with a preliminary sketch because there's not a whole lot going on here, right? I think we got a few asymptotes, vertical asymptotes, and a couple of horizontal asymptotes. Preliminary sketch at least starts to lay down some of the groundwork, so you're not sitting there at the end going, oh wow, I gotta, put it all together. Okay, asymptotes. Horizontal asymptote. Is there one? No, I mean ln x is just, as x goes to infinity, ln x is just going to get really large and then be squared. And then, so none. E. Intervals of increase and decrease. Okay, so what do we need to do here? Yeah, so, and at this point, calculus kicks in to the point of finding the, so we need h prime of x. I'm just for the sake of so if everything's on one page, you don't really have to worry about this, right? I'm just writing it back in again to remind myself, hey, what is this? So what is this? And we should put that together somehow. I could also go with x minus 2 ln x all over x, right? Just be aware of variance, right? I mean, just in case that's the question, is, okay, what's the derivative of this? And that's where you stop, but that's not what you see. All right, so now what do we need then? Critical numbers, yes. So the next thing is the critical numbers. So are there any critical numbers? So it can't be 0, right? Because that's not in the domain. 0 would be critical, but you can't be 0 because it's not in the domain. So I don't think there's any critical numbers, right? Right, not in the domain. Given the domain, there are no critical numbers. All right, so then what we're interested in, then, what's the sign of this? So 1 minus 2 ln x over x.
Just 1 squared over 2 ln x equal to 1, right?
How, what?
If you're looking for critical numbers, wouldn't it just be points where 2 ln x is equal to 1?
If 2 ln x were 1, what would x be, and would that be 1?
Oh.
Yeah. Can we make 2 ln x over x equal to 1?
Yeah.
Okay. Yeah, but I don't think so. So there are no critical numbers. Okay, so all we're interested in is find what's the sign of this. So this function will always be increasing or always be decreasing. We just need to figure out if 1 minus 2 ln x over x is greater than 0 or less than 0. So I guess the question is 2 ln x bigger than x or smaller than x? For all x. All right, so let's think a bit. Okay, so here's y equals x. Where does ln x fit on this? And 2 ln x. I don't think 2 ln x is going to be much huger than ln x. So ln x looks kind of like this, right? And if you think about it, I mean, what's ln x? It's the reflection of e to the x. All right, well, we know what e to the x looks like. So that means that x must always be bigger than this, right? And multiplying this by 2 is going to make it cross, right? Be like going 2e to the x. Okay. So you think about it that way, and you're saying, all right, so if x is always larger, then 2 ln x over x is always going to be a fraction, let's say, right? A number less than 1. So 1 minus a number less than 1 is always going to be positive. Okay, so h prime of x, so we can just say here, always positive. So h prime of x is increasing on the interval 0 to infinity. Okay, so good, we're going to increasing. Max or min? No. No local max or min, right? Concavity. So this matters, right? You know, maybe just because it's increasing doesn't mean it can't be concave up, concave down at certain intervals. So what do we need to do here? So this is concavity and points of inflection. So we need the second derivative, right? And what is the second derivative?
Shouldn't it still be negative? 0 minus something?
Yeah, well, it's a negative of, so then this changed to negative and this became positive.
Oh,
so I flipped them down.
See that.
Yeah, that's you gotta watch out for it, because that 1 in front, so the derivative of 1 is 1, but then it's minus. So the derivative, derivative of 1 isn't 1. So the derivative of 1 is 0, so it's 0 minus, and then you gotta do the derivative, right? The sum difference stuff. Jesus, end already.
Is Jesus living in his throat?
Does he not live in us all?
No.
I don't believe in that.
Maybe that's why you're coughing.
That could be, yes. It's oh, what's he got against me? Nothing. All right, so when is this 0, right? Because then we'll have some concavity going on. So h double prime of x equals 0 means that ln x minus 1 is 0. So ln x is 1. So what's x? E. So x is e. Right.
I'm kidding.
It's the You're just changing from logarithmic form to exponential form, right? Ln is log base e, so the base is e, the exponent is 1, and the value is x. Okay, so then we have 0, and we have e, and we have a 2, and we have a ln x minus 1, and we have an x squared. It's going to be like one long page, which gives us the sine of h double prime of x, which gives us the concavity of h of x, and should we have concave up and concave down, then we'll have a point of inflection. So x squared, well, that's always possible. The ln of e, well, I think if we go up here, then we probably get that. And so we have our sine. Show me a sine. Okay, so we have a point of inflection at x equals e. So h of e is e minus ln e, or e minus 1. So point of inflection is at e and e minus 1. And I don't know, we'll squeeze h in here. Sketch. Leave enough. Okay, so we have no, did we have an intercept? Yeah, it was at 0.49, right? Then we've got e, and if e were there, then e minus 1 is there. So we have a point of inflection here. So we are concave down, and we have the vertical asymptote, right? Which is here. And we're concave down to E. And then we're concave up. I don't know if that quite goes that high. So we should have like what, 0.49 or 0.495 apparently. And then E would be 246, 1, 2, 3, oh, it's 0.25575. So it'd be just a smidge over, be right about there. And then E minus 1 would be 1 point, the same, 78. So 25575. Yeah. So I guess I drew it a little climbier faster, but. Slow down. I think that's exactly the same.